Good morning, Year 5. I hope everyone's well. Today is lesson 12 of our series of fractions lessons. Today we're going to start looking at multiplying what we call proper fractions. So first of all, what is a proper fraction? We've looked at unit fractions so far, so a third, 1/8, 1/9, 1/15, so anything that has 1 as the numerator. A proper fraction is a fraction, any fraction other than a unit fraction, but it has to be less than the whole. So an example would be 2/5 or 6/9 or 7/10. These are all proper fractions. So the numerator is bigger than 1, but it's not become an improper fraction. In other words, it's not larger than the denominator. So these are proper fractions. We're going to be looking at these today and multiplying these using some of our strategies. Okay, so the first problem we're going to look at is 3 times 2/9. So the first strategy we're going to use is the same as we did yesterday with unit fractions. We're going to use repeated addition. So this time we want 3 groups of 2/9. So it's a simple matter of writing out our fraction 3 times 2/9 plus 2/9 plus 2/9. When we add fractions, the denominator stays the same, still ninths, and we end up with 6/9. 2 plus 2 plus 2, 6/9. That can be simplified down. 3 divides into both 6 and 9, goes into 6 twice, and 9 3 times. So 3 times 2/9 is equal to 2/3. That's the first strategy. Another way of displaying this is to do it visually. So what we could do, and I've also shown this on the PowerPoint as well if you want to have a look at that, is actually to draw it out. I showed you 2 different ways of doing that yesterday. I'll repeat one of the strategies I used yesterday. And this one would be to draw out our 9ths. And remember, you guys will be using rulers, and yours would be really nice and exact because you'd be measuring everything out. I'm doing this for speed. We have our 3 wholes, and they're divided. We're going to divide them into 9ths. So and then I keep going. I'll just double check this all in a second. I think this looks right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 8, 9. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have my 9ths, and if you want, you can label them all. Just to help you visualize. And I've actually used up 2/9, so I need to shade in my 2/9. I've got 2/9, 2/9, 2/9. In fact, now I can easily see when I count them up that I do have 2/9 here. So I've got 6/9 in total, excuse me. So I've got 1, 2, 3, 4, 5, 6, because this is 2/9, 2/9, 2/9. So all of this together is 6/9, which I simplify down again, just like I did before, by dividing by 3, which equals 2/3. So that's one strategy to use to solve this kind of problem. Okay, so let's look at another strategy. So here the problem is 2/10 multiplied by 3. So once again, I'm going to use repeated addition. We've done this several times. I need 3 groups of 2/10. So I simply write out 2/10 plus 2/10 plus 2/10. I'm using repeated addition, my 3 groups of 2/10. And now I solve. My denominators, my 10ths, stay the same. So my numerators I add. 2 plus 2 plus 2, which gives me 6/10. I can simplify this down. If I look at this, I know these are in the 2 times tables. 2 goes into here 3 times, and into 10 it goes 5. So I can simplify that down to 3/5. Remember, if you can simplify down, you must do so. Okay? So that's one strategy. Another one, and this is my preferred method in terms of visually representing it, is to draw a single fraction bar or a fraction strip. So this time I'm looking at tenths. So I just draw one strip. And I'm going to split this into 10 parts. So Just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. Each one is a tenth. Each part of this fraction strip is 1/10. But I've actually got 3 groups of 2/10. So each time I get a different coloured pen, you can see here, this is 2/10. Then I've got myself another 2/10. And then I've got myself another 2/10. I can shade these in. And then I can just simply solve. I've got 1, 2, 3, 4, 5, 6 out of 10, which is written as 6/10. And so I'm visually representing it, and I can simplify it down because I know 6 and 10 both divide by 2. And this therefore will become 3/5. So that's another strategy. I like this visual method because it's on one strip and I find it simpler than drawing the other one. But if you do prefer the other one, you're more than welcome to. And of course, you can use your repeated addition to solve this kind of problem. Okay, so I'd like you guys to have a go at this one now. You can solve it using repeated addition, or you could solve it using repeated addition and the visual method, or you can just use the visual method. I don't mind, but have a go at trying to solve this problem where you have to multiply a proper fraction by an integer, a whole number. So pause the video here and then we'll have a go through it together. Okay, so hopefully when you solved this independently, you looked at the problem and you realized that it was 3 groups of 2/7. So if you were using repeated addition, it would be simply writing out 2/7 plus 2/7 plus 2/7. Your denominator stays the same because the whole is still split into 7 parts. It's the numerator that will change. It's 2, add 2, add 2, so 2, 4, 6. So the answer you end up is 6/7. You cannot simplify that down. If you wanted to draw it, you would draw your bar. You guys will be using your rulers and presenting it beautifully in your books. You split the whole, the denominator, the whole is split into 7 parts. Just check 1, 2, 3, 4, 5, 6, 7. Each one is a 7th because it's split into 7 parts. And then you've got 3 groups of 7ths. So I'll highlight the different color. So here we have 2/7. Here we have another 2/7. And here we have another 2/7. And I can color them in to help you visualize. Then you just simply count them. Out of 7, I've got 1, 2, 3, 4, 5, 6. So I have 6/7. Once again, you cannot simplify that down. Well done if you got that right. One thing you might have noticed today is that we've focused primarily, actually only, on numbers and fraction problems that do not exceed or do not become improper fractions. So they do not go above 1 whole. We'll be looking at that tomorrow in tomorrow's lesson. For today, you have number problems at the end of the PowerPoint, and you also have some challenge questions as well, which I'd like to see some amazing written answers for and some explanations. The answers are also on the PowerPoint. Best of luck today, guys, and I will see you tomorrow.